Good morning. My name is Chinedum Victor, and this is my recording for the week 2 Flexi Saf Internship task. And the task is let's open the task again and see what we have here. The task says database. Okay, the lesson for the week is database architecture, and the activity here says high level design of a database schema to capture the entities and relationships for problem domain modeled as tables, keys, and constraint. And when you hear tables, keys, and constraint, you should know we're talking about relational database here. And that is that, and this is the task for the week. It said design a database schema for any domain of your choice and produce an entity relationship diagram ERD for the database. So before we proceed, just going to talk a little about database architecture. And database architecture is, as in, it refers to design structure of database system, which includes how data is stored, how data is organized, and how it is accessed. Or that is how it's retrieved. And it plays essential role in the efficiency, availability, reliability, and performance of a database. We should know that. And in database architecture, about 15 things are actually involved, but we're going to be talking just for the four that is within the scope of our activities this week. And the first one is the database management system, the choice of database management system. So when designing architecture, you make a choice, and this choice can either be relational database or non-relational database or NewSQL that's just brought by Google. And after that, we talk of data model. Make choice of the data model to use, and the data model can either be something like relational model that is table with rows and column, or it can be document model. Document model is the one that takes the JSON data, and it comes in collection. That is the MongoDB, then the NoSQL, and we have okay, then we talk about the schema. Let's go to the schema. The schema actually talks about, which is one of the major things you are doing in this week. The schema actually talks about it defines the structure of a table and the relationship, the constraint and normalization of data in the table. So that is that. Again, the last thing here we talk about is data storage, how data is actually stored in the database or within the table. So that is that for the task and the curriculum here. Then we head straight up to the schema that we draw. So I used this online visual paradigm site. It's actually a good site for making technical drawing and other like your UML and ERD them. So and I choose this project, a simple project, an install ERD, an install project that we can all relate to. So it has few entities here, which include the customer entity, the product entity, the cart entity, the payment entity, the order, wish list, and categories. And the relationships between them are actually spelled out very obviously here. And I'm going to show how that is done. So first off, to start your design, you just use this entity here to create entity. This for views, and this for triggers and whatever you want to include in your schema. And here is the tools for the relationship, connecting the relationship between entities. And here is one to one, here is one to many, and here is many to many, and you can get many to one. So, and let's go back to the schema again so we can discuss the relationship between these entities here. So here, if you look at the customer, you see that the customer has a one to many relationship with a cat. One customer can have multiple cats. Remember that a cat is actually a good, as in like any goods you add into your cart is an instance of a cat. So it's not the entirety of the goods you add that's actually a cat. So the instance of a goods added to the cart is the cart. So, and that's why if you add up to 3 goods in your cart, you have 3 carts, and that tells one customer you having 3 cards, one to many relationships. So I think that explains it very clear. So you can see this here. A customer can make multiple payments as many times as the customer makes an order. The customer can make a payment. So that is also one to many. Now here we have a different relationship, and that is many to one. You can see that many products can actually belong to one category. A product, as in so many products can belong to accessories. So many products can belong to gadgets. So your television is a gadget, as in home as appliances or whatever. So that is that for here. You can see that many products here connect to one category. So you can connect to one category. So that is that for the relationship here. So and if you study this ERD diagram very well, you see that the customer doesn't have any relationship with the product. Yeah, the customer doesn't have any relationship with the product. Only the cart and the wish list, the category that have access, have relationship with the product. So the customer has relationship with the payment because customer makes payment, customer makes order. Now, adds to cart. Here, customer can actually add to wish list. So, but in this we actually define, okay, let's make this because one customer can have many wish lists. I think this will be a good time to just add this. Let's connect this. I think it was missing out. Okay, let's connect this here. So good. Okay, one to many relationship. You see, let's push it a little forward, and that is how it works. Oh, it didn't connect what I wanted to connect. So let's go again, please. Let's go again. Good. So I think one to many. So now let's push it to where it's supposed to be. Good. So we see one customer can actually have many wish lists. Yeah, you can wish to make many like you're doing your Jumia. Okay, then we'll proceed to the database. Let me see how many times I have, many minutes I have. Okay, let's go straight to the database and do all this. Okay, so okay, as you can see in the ERD table, I have a customer, cart, product, and payment of these entities. And I've actually created few of the tables here. I'm just going to be creating one more for demonstration. And in this should be create table. Let me just start the whole of this afresh so we can get a better view. To create a table, I say create table. You give the table name, and the name of this table is going to be wish list. We are creating the wish list. So we then pass. Let's go. So we then give it our ID. Number one, our ID is going to be our primary key. Remember that in our curriculum we are covering majorly constraint and keys, tables, keys, and constraints. And here our ID is going to be the primary key. So we say serial primary key, and okay, let's check again. What do we have again? What's the next thing we have again? Customer ID and product ID. Customer ID and product ID are going to be our constraints because they are referencing to another table, and the data type is going to be big int. It's a better practice or best practice to save to store constraint as big int. So now the next thing again is product ID. Yeah, product ID, and that's another constraint. It goes with big int. And the next thing we're going to be doing here again is what's the next thing in the table? We have a price. Our price is supposed to be double. Normally, price can be double or big decimal, but in this case, we are using in case of Postgres, we are using double precision. Double precision. Okay, and sorry. With that being done, then we define our constraint. Now, this constraint is actually where we pay attention, because this is where we reference this column. This is a column here. This is a column in our table here, or an attribute in this entity. And we are supposed to reference it to where it belongs to the table that we're trying to relate or connect to. So, and in doing that, we're just going to say constraint, then foreign key. FK actually stands for foreign key, and we say customer ID. That is what we are. Oh, sorry, customer, the entity that has this foreign key. So we now say foreign. Sorry, don't want to mess things up. Okay, foreign. Oh, this is not a correct spelling for foreign. Oh man, what's going on? Foreign key, good. Foreign key, and the foreign key is gonna be this column here, this attribute we have here, which is customer ID. That is the foreign key here. So this is a foreign key in this table. So then we say foreign key. Then we reference the foreign key to the table we are connecting it to. So references. So reference it to customer table, and the attribute in the customer table or customer entity. When you're using table, you use column. When you're using entity, you use attributes. So the customer entity, the attribute in the customer entity we are referencing it to is the ID. So, and that is that for the customer. Yeah. So we can also do that for the product. So we're just gonna copy this, paste here, and we'll say product. Change this to product. We'll change this to product 2, and we change this to product. Yeah, let's see if we have any error before we execute. So, I think this is already double here. So, okay. Let me go over it again. Because this is just what we're going to be demonstrating. Let me go over it again. So this is the customer ID. This is the ID of this particular table, so that we can be referencing it to. This is the customer ID and the product ID that is actually a constraint in the table, and this is the price of the goods that the user is wishing to add to the wish list. And again, this is the constraint, as in this constraint here, this query here, this line of this query defines the table that all this constraint belongs to. So referencing to. So we close to the query, and execute. Good. Query returned successfully in the seconds, like you see, in for 20 milliseconds. That is how. So we've created our table. If we refresh our table here, you can see that we already have wish list added. Now let's just add a little thing into wish list. So let's use this one to insert something into the database. So we say insert into wish list. What are we going to be inserting? So we check the attribute we have there. So we have customer ID, then customer ID. Then we have what again do we have here? We have product ID, and lastly we have what? We have the price. So those are the stuff we want to add. And if we come here, we say values. So these are the attributes of the entity we are actually creating. Yeah, we are instantiating. So or creating, and this is the values we are passing to them. So sorry, if we do that, I've just passed customer ID customer 2. Well, I've already shown our customer table and what we actually have there. Customer 2, and product one, and the price, let's give it the price of $800. So now let's close this query and try to persist the data. Let's see what we turn out to. Oh, successful. So now let's retrieve our table. Let's query our table to see if our data was successfully persisted. We say select all from wish list, and if we close the query and execute it, it returns the table, and these are the data we actually persisted into the table. So that is all for today. This covers the entirety of the work. You can actually do all much again to see what we've done here, or the table here that we've actually persisted data into, sorry, like the product, you can see select all from product, so we can see what we have in the product here. So you can see we have, this is the product we have. Number one product, it's sneaker shoe, and it belong, and the price is $800, and the quantity is 120, and it belongs to the category one. So let's see what the category one is all about. So select all from category, and the category is shoes. So that is that for today. So you've seen the constraints, how they actually used, and the primary keys, and the table itself, and the rows and columns of the table from the schema that we drew, and the relationship between the schema, the entities, and that covers this. So I will be ending the video here today. Thank you so much.